Hey everyone, I'm Dominguez, also known as DMA, and appreciate when I'm called DMA. We started a series on functions, and today we will be discussing polynomial function. Let's have a look with me. We have polynomial function here. What is a polynomial function and how mathematicians denotate polynomial function? That's the form, the characteristic of a polynomial function. F of x equal to an, x to the power n, plus an minus 1, xn minus 1, plus we have 3 points denotating that could have more expressions included, a1, x, and plus 0. an minus 1, a1, and a0, in mathematics they are considered as constants. They are also called coefficients. They are numbers in general. And the exponent, which is n minus 1, 1, and obviously there is 0 there, x to the power 0 is 1, so there was no need to write it there. So the highest exponent is going to be the degree of the polynomial function. In this case, n is the highest one. So that's why we said the degree of this polynomial is n. So n is the highest exponent. So that means n is the degree of this polynomial. Of course, in the examples that we're going to be discussing, we will see numbers. Maybe n could be 7, 3, 4, and depending on the exercise that we're dealing with. And x is the variable. How do you differentiate a variable than a constant or than a coefficient? Just looking in f of x. F of x, the expression inside it is x. So that means x is your variable. If the inner expression was a, then a would be the variable. If it was t, then t would be the variable. And now comes the question. What happens if the degree of the polynomial function is 1? The highest degree is 1. So if the highest degree of the polynomial is 1, then we end up having a first degree function. So that's the function that we end up having. So first degree function, in another word, is a polynomial function when the highest degree is 1. We're going to analyze the domain, we're going to analyze the range and the intercepts and the graphs of the first degree first. We're going to analyze the first degree function first, all those points, and then we're going to analyze in the second degree function. What is a domain? Domain are all the values of the dependent variable, in this case is x that we're dealing with, all the values that satisfy the function. If there is at least one value that does not satisfy the function, then it can't be part of the domain. So domain, we are dealing only with the values that satisfy the function, and the range, the correspondence of each value from the domain. When you insert the value in a function, you get an answer. That answer is image, so that means it's part of the range. And we're going to analyze intercept. Intercept is where we find the equations. And we're going to analyze the intercept or x and or y. And finally, we're going to analyze the graph. Now, if we look at this first degree function, f of x equal to ax plus b. A and b, they are constants. A is the coefficient of x. What is the domain? Domain is all the values of x that is substituting in this function satisfy the function. In another word, f of x is a real number. When that happens, that means that value is part of the domain because it satisfies the function. But if you're putting a value in x and the result is plus infinity, minus infinity, then that means that value does not satisfy the domain. So it can't be part of the domain. But for the first degree function, any value that you substitute in x place, you will always have an answer. You will always have a real number. That's why we conclude that the domain for all first degree function is always the real numbers. So that's why we put from minus infinity to plus infinity. Now, what is the range? When you insert a value for x, obviously you will get a value for y. Y is equal to f of x. So for each value of x, you will have a value for y. All the values of y, the set of y values that you get after substituting the x, is called range. In the first degree function, any value of x that you substitute, you will always have a value for y. That's why also the range of a first degree function is real numbers. So from -1 to plus infinity. So any real number is part of the range as well. Now we have intercept. In intercept, we have all axes, which is y intercepting the abscissa axis, and that implies you calculating the equation by making f of x to be equal to 0. When you say f of x to be equal to 0, then you're going to be solving the equation to find the value of x. And then you have the intercept of all y, which means calculating the numerical value. That means where there is x, you will be putting 0, and then you will be getting the numerical value. So those are the fundamental procedures if we want to sketch the graph. For example, if we have this function, we have to sketch the function f of x equal to x, considering that x is between 0 and 2. X belongs to that interval. Usually when we are required to sketch the graph, they provide a specific interval for the values of x. If we not provided an interval, that means you can assume that's any real number. You can state your own interval from wherever you want to start to wherever you want to stop. But this case is different. But previously, we show when b is 0, when the coefficient here is 0, it always passes through the origin. Then we look at the coefficient of x. If it's positive, then the graph passes through first quadrant and third quadrant. If it's negative, then it's second and fourth quadrant. So if a, which is the coefficient of x, is positive, so the graph will always pass through the odd quadrants, and it will pass through the even quadrants when it's negative. So what happened is, we know from the notes that we took that the graph always passes here through the origin. That's what happened. F of x equal to x, that's the graph. But they say we don't want the whole graph. They stated the interval. They say from 0 to 2. They only want this graph from 0 to 2. So you look at the axis. From 0 to 2 is here. From 0 to 2. From 0 to 2. They only want from 0 to 2. So you erase the other parts that it does not satisfy the interval. So this graph from 0 to 2 is like this. So thank you for watching. If you like, subscribe, leave your comment, like, suggestion, and most importantly, share with your friends also. Thank you. I see you in the next video.